Let's welcome our speaker.
Hello everyone. I'm Guillaume Audou, layus on the website that matter. And today I want to share with you my work focused on reducing the Nix evaluation time in a very specific use case where we have like more than 300 packages and we want to evaluate all of them. As I like to say, we went from 5 minutes to 5 seconds, so it's pretty neat. I call this problem embarrassingly parallel because we have like this 300 package and we need to churn through all of them as fast as possible. There is like no connection between all the packages, just evaluate everything. Or at least that's what it looks like at first. This talk will take the form of an incremental improvements to a deliberately naive solution at the start. So yeah, we get started with very simple improvement, you get the idea, and then we move to more advanced topics. Don't hesitate to interrupt me with questions. I actually enjoy it, and I promise it won't throw off the talk. Questions? Okay, let's start with a bit of context. So this was done for, I'm working with Twig, but this was done for a company that's doing surgical robots. They have a huge code base, like lots of different target platforms. But they build with Bazel, and they use Nix as a provider of like third-party dependencies, mostly C, C++ libraries, but a ton of other stuff. Right now, we have 9 package sets in the sense that like their own STDN, and they target usually a different platform. There are like 230 packages, and because the same package can happen on different platforms, we need to evaluate like 460 packages. Like I gather some of the numbers for that talk when there was about 300, so I will keep 300 packages for the whole talk. I have taken some freedoms with the numbers, so it's more easy to count and compute. Like these are, I dropped commas wherever possible. So first, you need an introduction to what Bazel does. And Bazel declares Nix packages that can later be used by other rules in Bazel. So the first part that you see there is a declaration. You declare some hello package, and you give all the instructions on how to build it with Nix, like arguments and the attributes that you want to build, as well as, of course, like the source of truth, like where your Nix packages are, or your flake, or whatever. And then you can use it. In this case, you can use like the bin hello input, but you can also use like headers or libraries. And if you need to tune it, you can do it, of course, but this is not about Bazel. What happens in one of these rules is that your flake, let's assume it's a flake, exists somewhere in your workspace. What Bazel does is first make a copy of that flake inside the sandbox. And then it calls Nix build with that. And what Nix build does is makes a copy of the flake inside the Nix store. Because why not? Then you can evaluate it, and at that point, like, you use the attributes that you need to evaluate. But that's the only point where like the different rules differentiate themselves before the copying is the same for all the rules. Then in evaluation, you get a build plan, a .drv file. Then you realize it or build it. I mean, the term in the source code is realizing, but I don't know if anyone uses that. You get a package, and that's done with Nix. What Bazel does is like some symlinking and some like organizing of that thing to make it visible to Bazel. We don't care about these 2 last steps, basically because that is really fast. And that one is like, if you need to build a package, you need to build a package. I'm not going to make it faster. I mean, I can do it, but it's on a per package basis. It's not like changing the infra. So I just don't care that much about that. And I will focus on the 3 first phases there. There. So if we do it with 300 packages, you can compute it. It's like 13 seconds times 300 packages. I mean, it's 1 hour of CPU time. Of course, you can parallelize it. It's how you make things faster, right? You just like throw more CPUs at it, and it takes 8 minutes. That's kind of slow, and at that point, we really needed to do something. And as I said, the first part is really dumb. We are doing the same copy operation 300 times, and it's the same thing. So, of course, we want to split it, do it only once, and then share it, which is not that trivial because we need to share a flake that is already in the Nix store. So we need a way to send our files to the Nix store. How to do that? I mean, if you have any ideas, just come with it. But I found a very complex way because I had to replicate like the git command with ls files because we want the files that are like under version control, but we want the version that is like currently in the workspace and not the one that is checked in. So you need to do all of that thing, and then you can copy it somewhere and then push that to the store. You need to name it source because that's how like flakes are named. And then yesterday it occurred to me that there is a very simple way to do that. Just nixflake metadata, it does it for you, just extract the path, and it happens to be a store path. So sorry about this very complex way, now I know how to do it better. But anyway, in the end, you have this flake path, and you can send that to all the evaluations. So now we've gone from like 300 times 13 seconds to 12 seconds plus 300 times 1 second. Okay, we are like to 5 minutes of CPU time from like 5 minutes of CPU time from 60 minutes. It says seconds, sorry. And if you parallelize that, I mean, of course you need to pay the first 12 seconds because you can't parallelize anything if you don't have the inputs. But afterwards, you can parallelize this 300 times 1, which is much faster. We get like 50 seconds world clock time. That's an improvement, and it was kind of easy, of course. Now we want to do that with the evaluation itself, which is the crazy part. And I think there is something to gain by like evaluating all the package together. Afterwards, we are evaluating different attributes in the same flake. So ideally, like logically, they should share some overlays, they should share some fixed point, they should share some stdns, and all of that you should not evaluate that many times. There is possibly some things that we could like some optimization to get from merging that together. So if we first split it like that, which is not trivial, we need to be able to transfer from one Bazel task to the other something, and in that case, the something we want to transfer is the .drv file. Well, not exactly, because we need more than that. We need the .drv file and the outputs to install. Right? When you nix build something, it implicitly goes through the outputs to install and does it for you. But if you are playing with the .drv file, you need to also take that logic into account, which will complicate things quite a lot. Ideally, after that, we just merge everything into one nix instantiate, generate all the DRVs, and we're done, right? So I made an experiment. I did the nix path info derivation. This is supposed to print me like the DRV file of all of these things. I mean, it's ChatGPT generated, like doesn't mean anything per se. But like, imagine there are 300 packages there on that command line. And you see, I passed 300 packages on the command line, but on the output, I get like 285. What happened? How come? It just turns out that some of these packages end up to be the same derivation behind the scenes, which is totally fine. But what's really annoying for me is I cannot map because like, I don't know which one maps to which one. And it's even worse than that, because they are sorted by the hash of the path. So there is literally no way you're going to map these outputs with the input packages. I didn't find a way around that. Oh, yeah, okay, whatever. So, thankfully, Elko wrote something when he was still working at Twig that's really useful. It's the Nix evaluation cache. And the thing is, once you have evaluated it once, like for all of these attributes, it's there in the evaluation cache, and it's really easy to access. It's in an SQLite database, and Nix will just fetch it for you very easily. So, yeah, but no, we still need the outputs to install. That doesn't work. It's not provided by the API. But interestingly enough, it's also in the SQLite database. It's just not exposed. So you know what you do? Just open Python, try to find where the flake is. So you get the hash from one database, and then you get the log file content. You create a string that you can hash that gives you the hash of the second database where you can extract all the data. And there you can find the .drv path and the outputs to install. That script is much faster than calling Nix, by the way, because Nix needs like some startup and whatever. So if you do everything in one batch script, it works pretty well. So now we have transformed our problem. We need to populate the cache, and then we can extract anything we want. Okay? So we just run Nix path info derivation with like all of the packages. And it takes 15 minutes. 15 minutes, if you remember, it's like 900 seconds, which means we have 300 packages times 3 seconds. For each of these packages, Nix is making a copy to the store that takes 2 seconds, and then evaluates it for 1 second, then discards everything and starts with the next package. It's a for loop. It doesn't take any benefit from having all the packages together. It really bugs me. Luckily, we already have a flag that's a store path, so we can use that. If we do it, then we only pay for the 1 second evaluation of each of these packages. The state is still discarded, but we don't pay for uploading it to the store. So that's 5 minutes. That's my 5 minutes that I started with because, I mean, all of that was kind of in place when I started to optimize it. Then I wanted to go further, and all of these packages come from the same flake. So there is actually a Nix value that represents the flake in the source code, and if we can keep that one, then possibly we can just pay the incremental cost of evaluating one more package in something that's already fixed, like all the overrides resolved, all the package, all the overrides, whatever. That's actually a huge cost. So I made a PR for that. It was merged. And I was really happy because then we are down to 31 seconds for that evaluation, which means that the marginal cost of evaluating one more package is 1/10 of a second. It means that 90% of the time is spent of kind of boilerplate that's applies to everyone, and then 10% is a bit more specific to a package. There is a lot of work that needs to be done, the way we assemble Nix package. Every time you create a package set, you go down from bootstrapping steps to all the different layers until your final package set with all the overlays. That costs kind of some time. But still, from 5 minutes to 31 seconds, it's you pay 1 second for the first package, then 1/10 of a second for the 299 that remain. Basically, it's 31 seconds. Can we be faster yet? And now the answer is as always, if it's not fast enough, just parallelize it, right? So we chunk it, take about 38 packages for each thing. We run 8 copies in parallel. Amazing, it's 5 seconds. Well, 4.7, but who cares? So it's 5 seconds. I am there, it's done, it's working. And then I run Python extract from eval cache, and it just crashes. It crashes because I have run all of these Nix path info in parallel, and they are all trying to write to the evaluation cache. And it doesn't work like that, because it just takes one lock over all of it, and so the first one gets the lock, gets to write to it, and all the others are I'm waiting too long for the lock, so I will just not write to it so I don't disrupt the flow. I mean, I rely on that thing. That's my flow. I want this evaluation cache to be populated. So back to the drawing board, I have this efficient parallel use of eval cache. It's just efficient in my use case, it works for me. But it's a bit slower. It's a bit slower for Nix search, twice slower, which is really bad. And it's effectively slower in many use cases. For me, it doesn't care because I reap so many benefits from it. But that's why it was not merged yet. Basically, what I do is introduce transactions for each operation on database instead of doing one huge transaction that prevents concurrent access and modifications. It's a work in progress. I have some ideas on how to fix it, but discussions, welcome, please help. That's fine. By the way, I would like to say something. It's probably not really important here, but I just love GNU parallel. So instead of writing these 8 things, you just call parallel, say I want 8 threads, make blocks of about the right size, I want 8 blocks of about the same time. You pass that to X args, which will just pass all the arguments to Nix, and then up, everything's working. You also need to cite it, but I mean, you know that if you use the tool. So, as a recap, yeah, I didn't mention, but then, I mean, it works for me, except it doesn't work for anyone else. The PR is available. You can patch your own Nix. We do patch Nix because at some point, it's sometimes it feels easier. We also patch Bazel. We patch everything in that company just for our needs. Well, yeah. So what we went from is this evaluation that takes 5 minutes because you evaluate all the package one at a time. We try to parallelize it, but it's not just as smart as, trying to reuse the state. When you reuse the state, then you can go down to 31 seconds of evaluation just because you only pay the incremental cost. And there you can, again, benefit from parallelization, which is kind of strange because you are doing some work multiple times, all the 8 threads evaluate the overlays and the base thing, but then they can churn through more packages, and so it goes a bit faster. I'm from these 5 minutes to these 5 seconds of evaluation. Right now, it's a bit different. There is only one Bazel rules that does all of the thing because I managed to get rid of the Bazel copy. 10 seconds again, wow. And then just copying to the store and evaluating can go like to the same into the same action. But basically, that's what's deployed right now. There it is. Any questions?
Thanks for your presentation. That was really enlightening. What I didn't get was you said you need to get the output from the derivation, and I didn't get because isn't the derivation holding the output path on the Nix board? But that's not what you meant.
DRV, like the .drv
yeah, the DRV.
file, it describes a build plan for all the outputs of a derivation, but usually I want only one in the end, and to know which one, to know like which one I should symlink in the end, I need to extract that information. Like NixBuild does it for you behind the scenes, but if you first get the DRV, then that information is lost, so you need to also fetch it. Maybe the JSON one, I don't know about that. I'm still living the world with that the .drv thing, maybe. So if it's in the JSON thing, then maybe it's way easier than what I used to. But okay, I need to check. I'm not sure.
Why are you all so far in the back?
Hey, great talk. Also battling with the cache. Just wondering, like, if the first bit that you did, getting the files from GitLS and so on, how often, because caches get invalidated the moment your Git is dirty, right? Mm-hmm. How often do you actually hit like dirty problem, like where the cache just gets blown away? You never persist the cache outside of Bazel?
It's persisted by Nix, and so basically, as long as the flag doesn't change, it remains there. And whenever the flag changes, then I need to evaluate everything, and hopefully most of the DRV files are the same. And so, like, Bazel stops propagating the change because it detects that you are like the same Nix package in the end. That's why it needs to be fast, because every change to your flag triggers this 5 seconds of evaluation. If it's like 8 minutes, it's really painful. 5 seconds, okay, right? I know I touched something Nix, so I pay 5 seconds, and probably I will build a package afterwards, so it's not really a problem.
Thanks.
If you don't ask the question, I have one question for you. Like, this is all about parallel evaluation, but apparently there is something like it's called parallel evaluation in Nix. And that thing is like, it comes from determinate systems, and they've like written a parallel evaluator. And that's not nice, because it was like, there was a blog post yesterday, and it was released like 2 days ago. And I spent the night trying to understand how it impacts my work and how different it is and whatever. But the way they do it, you have one, they evaluate one expression in parallel. So you need to turn your 300 package into one expression. You can do that. It's a bit ugly, like unsafe, discard, the string context, whatever. But you can create like a file that contains all the .drvs, and you can pass that to the determinate system installer, and it will evaluate your thing in parallel. So I wanted to compare it. I spent the night on like trying some proper data for it, and it's kind of interesting. I did not expect it. Well, the sequential evaluation is just like very slow, one package and one package and one package. It's faster because it's in parallel, so of course you get some benefits from it. What I call the shared evaluation is when you persist the state, so you only pay like the incremental cost, the marginal cost of adding more packages. And in that case, it's like also a bit faster because like it's on one thread with my Nix, and that thing has many cores. When we go to a single expression, you see it still decreases a bit. That I'm not quite sure why. I guess we are like hitting maybe like writing less to the cache, not quite sure. But if you use my parallel version with like 8 threads, then it's really funny because my version with like 8 threads is faster than the parallel version from the evaluator, which is like using 8 threads is more efficient than using the multi-threaded evaluator. I'm not too well versed into these details, but it seems there is some log contention over there. So maybe it's not clear who's the winner, and maybe there is some benefit from using both. Actually, it's really strange because if you do use both, you start like 8 processes with parallel evaluation enabled in there. Then you get like these 2.2 seconds, and that completely blows me. It's probably because I have like 68 cores and I can benefit from way more parallelization. But that's really strange. I think we need to investigate that. Can be really interesting.
Okay, I think our time is up. So let us thank our speaker again.